Now, what if we have a situation like this, where my atomic mass of chlorine on a 5 significant figure table is 35.453 AMU. Chlorine's got our two natural isotopes, okay? Chlorine 35 at 34.96885 and chlorine 37 at 36.96590. I want to figure out what is my percent distribution between these two isotopes. So how do I do that? Well, if I only have two naturally occurring isotopes, those two naturally occurring isotopes, when added together, should be 100%. So my chlorine 35 and my chlorine 37 should equal 100%. Now, when we do these calculations, remember we put our percents in decimal form, so it should also equal 1.00. Okay? So let's say I make X my chlorine 35. Okay? Well, then I have X plus chlorine 37 equals 1.00. So my chlorine 37 is going to equal 1 minus X. Okay? So now instead of having two variables, chlorine 35 and chlorine 37, now I have one variable because I have solved both of them for X. So now I can put them together in my equation. So I'm going to have my 34.96885 AMU for chlorine 35 times X as my percent distribution plus my 36.96590 times 1 minus X as my distribution of chlorine 37. And that will all equal 35.453. And now it's a matter of just distributing things out and solving for X. So I'm going to get 34.96885X plus 36.96590 minus 36.96590X equals 35.453. Okay, so I'm going to combine my like terms. So I'm going to combine my X's. Okay, and then I will go ahead and combine my non-X's on sides of my equation. So I'm going to get negative 1.99705X is equal to negative 1.5129, and X is going to equal 0.757567. Okay, so now remember, my chlorine 35 was X. So my chlorine 35 was 0.7576 or 75.76%. Okay? And my chlorine 37 was 1 minus X, okay? Or 100% minus. So if I do 100% minus, or if I do 1 minus my 0.7576, I'm going to get 0.2424, which works out to 24.24%. And if you remember the example that we did on chlorine a couple videos ago, that was our percent distribution for chlorine.